Hello. In this video, I will just demonstrate how to graph a linear function in two ways: the rise over run method and graphing by finding the x and y intercept. So yeah, that's what this section is all about, graphing. So yeah, just basically there are two methods of graphing a linear line. The rise over run method, where you basically start from the y-intercept and do the rise over run. And then the second way is finding the x and y-intercept and plotting those 2 points. So I will explain it. But before we go any further, I gotta make sure you know how to or I gotta review how if you forgot, I can review how to graph points on a Cartesian plane, because that's very important when graphing a linear function. So yeah. So the direction says plots the points 1, 2, 4, 0, 0, -3, -3, 2 on the Cartesian plane and label it A, B, C, D. Okay, so let's start with the first coordinate, 1, 2. 1 is like your x, 2 is like your y. So on the x direction, so you always start in the x direction and then go on the y direction. So on the x, you either go right or left, depending if it's positive or negative. And then for the y direction, you either go up or down. So our x is 1. So if you want, you can always start at 0, 0, but don't dot it, if that helps. So we start at 0, 0, and then we go 1 unit to the right because our x value is positive 1. Don't dot it yet, and then go, our y value is 2, so go up 2. Okay, so it'd be right here. So this point here is 1, 2, and then just label it A. That's it. That's how you graph the points on a Cartesian plane. So let's do the next one. 4, 0. 4 is your x, y is your 0. So you can start at 0, 0, and then move 4 units to the right. And then your y value is 0, so you don't go up or down, just dot it there. Okay, so this is 4, 0, and then this is going to be B. And then C would be x, y. So you start at 0, go down at -3, dot it. Okay, so that would be label C. And then finally D, -2 is your x, 2 is like your y. So you go start at 0, 0, and then go 3 units to the left because our x value is negative, and then go up 2. So you can call this point D. Okay, so that's just a little review. If you already knew that, that's perfectly fine. Okay, so now let's actually start graphing. So on example 1, it says graph the linear line, and we have y equals -1/2 x plus 2. So we have y equals, I'll write it again, -1/2 x plus 2. My advice is, if it's in y equals mx plus b, right? That's like slope intercept form. I would just do the rise over run method. Unless, the fraction is really like a decimal, then I would not do the rise over run method. So we're going to graph this linear line using the rise over run method. So we need two things. We need the slope, and we need our b, our y-intercept, which we both have. So what is our slope? It's the number in front of x, so it's -1/2. What is our b? It's the constant, so it's 2. B is also the y-intercept, so I'm going to label it as 0, 2. Okay, because we're gonna plot it, right? So the first step of the rise over run method is plot your b. So plot 0, 2. So you start at your x value 0, and then you go up 2. So it would be right here. Maybe I should use darker color. 0, 2 would be right here. Okay. And then from there, we do our rise over run. So our slope is -1/2. What that means, it's your rise and it's your run. So what you do is you go up 1, and then because we're going negative, we're going to have to go 2 units to the left. 1, 2. Now, did you know you only need a minimum of 2 points? Really, yeah, that's if you have 2 points, you're good. But you can continue the process. So you can go up 1 and 2 units to the left. 2. So it'll be right here. And also, did you know that there's you could actually go from the B from 0, 2, you could actually go down 1, and then 2 units to the right. As long as you're going on the negative direction, you're fine, right? So there's 2 ways you could do this. So you start at your B 0, 2, you could go up 1 and then 2 units to the left, or you could go from the B, go down 1 and then 2 units to the right. Okay, connect the dots as straight as you can, and that's it. Okay, so you label this y. You always label your graph y equals -1/2 x plus 2. Okay, go ahead and take some time to copy and pause. And then let's move on to the next one. Okay, so graph the linear line x minus 3y equals 6. So this is still technically a linear line. It just looks a bit off, but what form is this linear line is? So in the previous section, we went over all the equations that are related to a linear line. And then this form is what's called in standard form because you have all the letters on one side and all the constant on right. So standard form is ax plus by equals c, right? Okay, so what you're going to do, so if I had a linear line in standard form, I would not do the rise over run method. You can do it. I just think it's more work. But if it's in standard form, I would just I would graph this by doing finding x and y intercepts. That's my opinion. I mean, that's how I would do it. You don't have to do it my way, but yeah. So yeah, let's graph this using finding the x and y intercept. So let's start with the x-intercept. So how do you find the x-intercept for any graph? It doesn't matter if it's a linear, quadratic, rational. You simply plug 0 into y and solve for x. That's it. So if you look at our equation, you plug in 0 for y, so it's x minus 3, replace y with 0, equals to 6. Okay, so this cancels, so you're left with x equals 6. Now, I will put it in a coordinate because I do have to graph it, or you know that it'll be somewhere on the x-axis, but if you want to write this as a coordinate, it would be 6, 0, because any point on the x-axis, the y value will always be 0. Okay, so go ahead and plot that. That would be 1, 2, 3, 4, 5, 6. So here's 6, dot it. This is 6, 0. Okay, now let's find the y-intercept. So how do you find the y-intercept for any graph? It's kind of like the opposite. You plug 0 into x and solve for y. Okay. So you plug in 0 for x, so that would be 0 minus 3y equals to 6. divide this by -3. 6 divided by -3 is -2. So how do I write this as coordinate? It would be 0, -2, right? So let's plot that point. 0, -2 is right here. And then remember how we said you only need a minimum of 2 points? So go ahead and connect these two dots straight as you can. Oops, I'm trying to make it as this is probably the straightest I can be. And then always label your graph. So this is going to be x minus 3y = 6. Okay. So yes, that is how you graph this linear line. Okay, go ahead and pause and let's move on to the next one. Okay, example 3, we have y = 1 minus x. So what form is this in? Is this technically in slope intercept form? It's in y = mx plus b, right? But be careful with this one. It's slightly off, right? See how they put the constant first and then the variable at the end? We want the variable first and then the constant at the end. So let's rearrange this equation as y = -x plus 1. Okay. So all I did was I rearranged it because I think it would be a lot easier. And we're going to use the rise over run method because it's just much easier. So because it is in slope intercept forms, so we're gonna definitely do the rise over run. So first thing first is we got to find the m and the b. So what would be my slope? It's the number in front of x. So there is a invisible -1. So -1, or you can say -1 over 1. And what is my b? My b is 1, the constant, or if you want to write it as a constant, 0, 1. Okay, so go ahead and plot those. Start with your b, so 0, 1 is right here. And then our slope is -1 over 1, so that means we're going to the negative side, the left side. So you can either go up 1, left 1, up 1, left 1 again. And then, or you can actually go from the b, you can actually go down 1, right 1. As long as you somehow, as long as your slope goes to the left because it's negative. Down 1, left 1. Okay, connect the dots. Label it y = -1x plus 1. Okay, okay, go ahead and copy and write down. And I'm going to stop here because I don't want to make these videos too long. So there will be a part 2.